with optimization, we are going to try to be either max or minimizing an objective function subject to a constraint, and that constraint needs to be an equation. So what you see here is that with our optimization process, we first need to find the function in one variable. We'll use the constraint to get the function in one variable if necessary. Then we find our critical numbers by looking at where f prime is equal to 0 or does not exist, and then verify that it's a max or a min using our number line. So with this question here, we're given a cost function and a revenue function, and we are asked to find the profit function. So our profit is equal to revenue minus cost, and anytime we subtract off our cost function, we have to change all of the signs of the cost function because we are distributing that negative to all of the cost. All right, so what we'll do is we'll plug in our revenue function, which is given here, negative 1/2 x squared plus 1,000x minus our cost function. And again, we're changing all the signs here. So the 5,600 was positive. It now becomes a minus 5,600. And then the 400x was positive. It now becomes a negative 400x. So we can combine some like terms here because we have a 1,000x and we also have a negative 400x. So if we combine those, we get 600x minus 5,600. Okay? Now, if I just gave you a function and said we want to find the relative extreme or relative minimum, what you would do is you would take the given function and you would find its derivative, set it equal to 0, and then draw your number line. So that's exactly what we're going to do here. We have our function, and so now what we are going to do is we are going to take its derivative. So we take p prime, again we'll bring down the 2, and when you bring down the 2 you get negative 2 over 2x, so that just becomes negative x, and then plus 600, the negative 5,600 becomes 0. So we set that equal to 0 in just the same way that we did before we talked about optimization and when we were just trying to find relative min and max. So we have negative x plus 600 is equal to 0. It's a linear equation, so all we have to do is isolate x. And the easiest way to get a positive x on one side is to just add x to both sides. So we get 600 is equal to x. Now, that is our critical number, and we have to draw a number line just to verify that that critical number actually does give us a max. So what we'll do is we will plug into our derivative a number to the left and to the right of 600. So for example, I could plug in, let's say, 0 into the derivative, and again, I'm plugging it into this negative x plus 600 because that was our p prime after we simplify. So we'll have 0 plus 600, and that gives us a positive. And then we'll plug in some number to the right of 600, so we might plug in 1,000. So that will give us a negative 1,000 plus 600, negative 1,000 plus 600, and so that gives us a negative. So because we're looking at the first derivative, that indicates when we're increasing and then we are decreasing. And so we see that 600 does in fact maximize our profit. Now, keep in mind that X here represented the production level. So this is telling you that you need to produce 600 units in order to maximize your profit. So in coming up with your equation, not your equation, but your final answer, what you would want to do is you would want to say that our profit is maximized for a production level of 600. Now, the actual profit will be given by the profit function. And our profit function that we found in part A was negative 1/2 x squared plus 600x minus 5,600. So to find the actual profit, we'll have to plug in our 600 into that profit function, plugging in x is equal to 600. So we'll take negative 1/2 600 squared plus 600 times 600 minus 5,600. And that will give us 174,400. And that is our actual profit. So we'll say the profit is $174,400.